Hello students, let us discuss some conversions in this video related to the chapter Haloalkanes and Haloarenes. It is one of the textbook question, that is question number 19, how the following conversions can be carried out. Here some of the names of a organic compound are given. You have to convert one compound into another by following the different reactions which we have already discussed. So let us try this one by one. First one, propene to propane 1-ol is given to us. You have to convert propene into propane 1-ol. So here for this, first of all, we need to make the structure. This is a structure for propene. This is a structure for propane 1-ol. So you have to convert this into this. But you need to follow the different reactions which we have discussed, and you have to follow that equation and you have to convert in this way. So first of all, whenever a question is given for conversion, first of all count the number of carbon atom. First you have to check that whether the carbon number is same or not. So you have to count it. When you count it, it will be found that 1, 2, 3. Here there is 3 number of carbon atom. 1, 2, 3. Here also 3 number of carbon atom. That means the carbon atom is same in both the structures. So in that case, what we need to do here, then we have to identify that the compound is changed to which type. So here it is an alkene and here it is an alcohol. So till here you have not learned any equation in which directly alkene can be converted into alcohol. So follow in the reverse way, think in the reverse way. Like we have learned the reaction of alkene, that the alkene can give rise to halide. That we have learned that alkene can give rise to halides and halides can give rise to alcohol. So think in the reverse way. So we know that from halides we can prepare alcohol and from alkene we can prepare halides. So that means there should be a halide in between the two structures which is given. So that means you need to convert the propene into a suitable halide. So how you convert a alkene into a suitable halide? So that is a reaction with HBr. The reaction with HBr give rise to halide. But for the reaction of HBr, you have to follow the two rules. That is, either you have to use Markovnikov or anti-Markovnikov rule. So make a trial here. Use the Markovnikov rule. When you use the Markovnikov rule, so you will need to break this bond and you have to add one Br here and one H here. So you will be getting a product like this, that is CH3 CHBr CH3. So you will be getting a product when we use a rule, that is Markovnikov rule. When we use Markovnikov rule, we'll be getting this product. So now when we do a nucleophilic substitution in which the OH will be removed and it form OH. So when you do this one, you will be not going to get this product because in this product OH group is on the first carbon, but here the OH group comes on the second carbon. So definitely the rule which we have used, Markovnikov rule, will not give the suitable product. So what we need to do here, we have to use the another rule, that is anti-Markovnikov rule. So whenever you are doing a conversion, make a trial. If one possibility is not okay, try the second possibility. So now you do anti-Markovnikov rule. When you do in the anti-Markovnikov rule, that is the reaction with HBr. When we do the reaction with HBr, so you will be using an anti-Markovnikov rule, so you need to use peroxide. So when we are using peroxide, we will be getting a product like this, CH3 CH, because here this bond will break, here one H, here one Br. So we'll be getting the product like this, CH2, CH2, Br. We'll be getting the product like this. Now when you do the substitution, that is aqueous KOH, when you do the substitution at the time, this Br can be replaced by OH. So you can find out the product here. Now the Br is replaced by OH. So this is the correct way of doing by using the anti-Markovnikov rule. So let us check the answer. When you find it, the answer here, what is the answer here? That is, a conversion takes place to the formation of this product, and then this product is formed. That is a propene to propane 1-ol. Next one, the conversion 1-bromopropane to 2-bromopropane. As I told you, first find out the number of carbon atom after making the structure. You can find out there are 3 number of carbon atom here. Here also 3 number of carbon atom. So when the carbon number is same, that is not a big problem. But the carbon number, if it changes, you have to either add a cyanide, CN group. CN group can be used for increasing the carbon number by 1. Or if we need to double the carbon atom, then at the time you have to use the Wurtz reaction. So here the carbon number is same, so we cannot use the cyanide and Wurtz reaction here. Now in this case, what is actually the change? The position of Br is changed. Here the position of Br is on the first carbon, and here the position of Br is on the second carbon. So whenever such type of question comes, when there is a same number of carbon atom and the same group, but there is need to change the position at the time, the use of rules, that is Markovnikov and anti-Markovnikov rule, is the best method, suitable method. So let us try this problem. So in this case, Br is on the second position. So that we need to convert by using any rule. But for using that rule, we need an alkene. We need an alkene. So how we make a halide? This is halide. How we make halides into alkene, first of all, that we need to discuss here. So which reaction give rise to alkene from halide? From halide to alkene, which reaction gives? That is dehydrohalogenation reaction or beta elimination reaction. So let us do the beta elimination reaction. Beta elimination reaction, that is a removal of halogen group and one of the beta hydrogen. Here one beta hydrogen is there, that is removed. So when it get removed, it will be result in the formation of alkene. So when we make the alkene, you will get the structure like this. That is, after the removal of Br and one H from here, we get the product CH3, CH double bond, CH2. This is an alkene. Now we need this product. In order to make this product, there should be one Br group on the second carbon. That means we have to add one Br here. So I told you the best method is use the rule. That is addition of HBr. Addition of HBr, and which rule we have to use that which give rise to this product? That is Markovnikov rule. When we use the Markovnikov rule, then only the Br comes on this carbon atom. When you use anti-Markovnikov rule, the Br comes on this carbon atom. So which product we need? We need this product. So in this product, Br is on the second carbon atom. Therefore, we have to use Markovnikov rule. So when we use a Markovnikov rule, we get this product. So let us check the answer for this. So this is the answer. So in this answer, you can find out, first we have done dehydrohalogenation. There is a formation of alkene, and when we use the Markovnikov rule, we got the suitable product. So this is one of the method for converting one compound into other compound, but only the changes in the position of the group. Next one, toluene to benzyl alcohol. First of all, you should need to draw the structures. This is toluene, this one is toluene, and this one is benzyl alcohol. Benzyl alcohol and toluene. So in this there is a common thing. What is the common? Both are aromatic compound. And when you check the number of carbon atom, here there is single carbon atom on CH3 and here it is also CH2OH. That means when you compare here, both have same number of carbon atom. So there is no need of extending the carbon atom. So we need not use the cyanide here. So let us check what are the other possibilities we have here. Now in this case, first of all, we are converting a hydrocarbon into alcohol. So when you check the structure here, this is an hydrocarbon, this is an alcohol. So directly hydrocarbon into alcohol, you have not learnt any equation. So what are the indirect method? We know that when this part is a halogen part, so then it is called as a benzyl chloride. For example, if this part is CH2Cl, so if this, it is easy to make this product. That means you have to add one Cl group, that is called as a halogenation reaction. So when we do a halogenation reaction, we get this product. And this product, that means a halogen can be substituted, can be removed and can be OH group substituted by using a nucleophilic substitution reaction. So the correct answer that first of all it is converted into benzyl chloride, then the benzyl chloride is converted into benzyl alcohol by using substitution. So let us find out the answer for this. So when you find it out here, the answer, so you can find out that in the toluene, first of all, one CH3 Cl group is added by reaction with the chlorine in the presence of H nu, and the Cl group we have to substitute by OH group by using the reaction, that is reaction with the aqueous QH, that is a nucleophilic substitution. So this is a equation, that is a conversion of toluene into benzyl alcohol. Next, conversion of benzene into 4-nitrobenzene. So this is also aromatic compound. So in such a case, you have to follow the aromatic reactions. So here benzene, it is an hydrocarbon. You can find there is no group on this all, but here there is one Br group and NO2 group, nitro group. So we have to substitute a bromo group and a nitro group. So we need to take a substitution reaction. So that is electrophilic substitution. So first of all, we'll be doing electrophilic substitution for the addition of Br, that is bromination. When we do the bromination, we get bromobenzene. We get bromobenzene. And then we do the nitration, so we'll get this product. And we know that for halides, that is for aromatic halides, when we do the electrophilic substitution, that is a nitration reaction, in that case it gives rise to ortho and para product. So here you will be getting a para product. So that is the reaction. Let us check the answer for this. So here you can find out, first of all, we have done a halogenation. Halogenation of hydrocarbon give rise to halides, but it is an aromatic halide, that is bromobenzene, and when we do the nitration, so we'll get a nitro group at the para position. So this gives rise to 4-bromo-nitrobenzene. Next one, benzyl alcohol to 2-phenyl ethanoic acid. So first of all, make the structures for benzyl alcohol. This is the structure for benzyl alcohol, and this is the structure for 2-phenyl ethanoic acid. It is an ethanoic acid, but on the second carbon atom there is a phenyl group. So it comes and the numbering should start with first carbon, that is acidic carbon is the first carbon, this is the second carbon. So the phenyl group is on the second carbon. So this is the structure for 2-phenyl ethanoic acid. Now count the number of carbon atom. I told you always find out the difference is there or not in the carbon atom. So when you count it out here, this group is similar here, but what is the difference here? CH2OH, that means here there is one single carbon atom and here there is 2 number of carbon atom. So whenever you can say that there is a difference in the number of carbon atom, so you have to use any other method by which you have to increase the carbon numbers. So what is a method for increasing the carbon numbers? Usually whenever there is need to increase one carbon atom at the time, the use of cyanide product is the most suitable method. So by that we can increase one number of carbon atom. So let us make the use of convert this into cyanide. So the reaction, we know that cyanide can be given a product in a nucleophilic substitution, but nucleophilic substitution takes place for halides. So we need to convert this product into first a halide. So how we convert this into a halide? Alcohol into halide. There are large number of reactions in which alcohol can be converted into halide, that is SOCl2, PCl3, PCl5. There are different methods by which we can convert the alcohol into halide. So we'll be using any one of this method and we'll get the product, that is benzyl chloride. So benzyl alcohol is converted into benzyl chloride, and by the nucleophilic substitution, that is by KCN, by using the KCN we'll get the product, that is cyanide, CH2CN. Now you can see the number of carbon atom is increased by 1. So when you find it out, here there is one carbon, here there is one carbon. So the carbon number is increased. Initially we have only one carbon, now there is 2 carbon atom. As in the product there are 2 carbon atoms, so we have increased the number of carbon atom. Now how we convert the cyanides into an acidic group? So for that we have learned the equation, that is RCN. When we do the complete hydrolysis give rise to RCOH. So we need to follow that equation. So in that case we can say that the CN group is converted into COH group. So that is the equation, that is a complete hydrolysis. On the complete hydrolysis give rise to CN into acidic compound. So this is the correct way of doing this conversion. So let us take the answer. So here is the answer. You can find it out that first we have converted into benzyl chloride, then into benzyl cyanide. Because there is need to increase the carbon atom, so we have converted into benzyl cyanide, and when we do the hydrolysis, that is a complete hydrolysis, give rise to the acid. So this is the correct way of doing this conversion. Ethanol to propanenitrile. This is ethanol and this one is propanenitrile. Look at the structure, how we make propane means 3 number of carbon atom, 1, 2, 3. There are 3 carbon number atom, and because there is no other substitute or no other functional group, in that case nitrile is a functional group here. So CN is a functional group here, and because the functional group consists of carbon number, so we have to take that carbon number as the first carbon atom. So this is 1, this is 2, this is 3. So we can say that there are 3 carbon numbers in the main chain. So we use the word prop. So we have used prop and all are single, therefore propanenitrile. CN group, when it comes in the functional group, then we use the word nitrile. So that is the structure of propanenitrile. Now when you check the structure here, when we count the number of carbon atom, you can find it out that in this 1, 2 carbon atom, 1, 2, 3 carbon atom. So you have to increase the carbon number. How we increase the carbon number? By using CN. And here product also need a CN, that is cyanide group. But there is no direct reaction of alcohol into cyanide. But we know that cyanide can be substituted if there is a halide group here. That means if there is CH3, CH2Cl, in that case the OH can be replaced by Cl, so we get this product. And when this product we do the substitution, we get this product. So when we do the substitution, we got this product. So how we convert alcohol into Cl, that is a alkyl halide? There are so many equations, that is COCl2, PCl3, PCl5 or any other reaction. So by any of this reaction you will convert into halide, and then we do the nucleophilic substitution, we get this nitrile. So this is the correct way of doing this conversion. Let us check the answer. So in this you can find out, first we have added the Br we have done, we got bromoethane. When doing this KCN, aqueous KCN, we got this product, that is propanenitrile. So this is all are the some of the examples which we have discussed, that is a conversion. The main thing for doing conversion is you need to learn all the equation, then only you can do the conversion. And always think in the reverse way. You find it out from the last product, what can be, how can we come to this product. So like this you will be getting the correct way of doing conversion. So this is all about this video. Thank you everyone.